Hello everyone. So now we're on to the sixth problem, and in my opinion, the by far most interesting one. So yeah, let us begin. So just to start out, what do we have? We are supposed to show that minus pi over 2 is less than the sum where n goes from 1 to infinity of a over 8 squared plus n squared, which is less than pi over 2. And this is supposed to be true for all real a's. So how the fuck do we do this? We have to split this up into case. So we have case 1, a is equal to 0. That just obviously holds because then the sum is equal to 0, which is in between. So that works. So now we have case 2, where a is larger than 0. Then we have this little sum here that we can denote. Therefore we know that, okay, these are positive, so therefore this function is strictly positive. And with respect to n, it is decreasing. It looks roughly something like a bell-shaped curve with respect to n, that is. Changing the a here only like stretches it. So what can we say? Since, okay, so we're only considering positive n, and we know that it's decreasing with respect to n, so then, okay, these are the same. This is the sum. I just shorthand note. So therefore we can say that, okay, so we're counting the sum from 1 to infinity. Can we maybe compare this with some integrals? Yes, we can. So this one is obviously, if you arrange the partial sums in a certain manner, you will realize that this is less than the integral from 0 to infinity of a over a squared plus n squared dn. And likewise, it is larger than if you arrange the sums to the right and then compare it with the integral from 1 to infinity. Then you would also see that this sum is then larger instead. And for both of these integrals, we do a variable substitution. So we let u, because we want to cancel out the a squared here. So basically what we want to do is that if we were looking for an arctan solution, what would we do then? Well, we would want it to say a squared times u, so we can cancel out the u's and just have 1 plus u squared down there. So what would we have there? Okay, we want to switch n for au. U has to be n over a, meaning that du dn is equal to 1 over a. So we do that for both of these guys, so therefore that is equal to, so we now instead we start at 1 over a, and then we still end at infinity, and then we have, okay, so dn is equal to du times a. So therefore this becomes a squared over a squared plus a squared times u squared, and then all the a's just disappear, du that is. And this thing here just becomes, well, this is just arctan of u from 1 over a to infinity. And the guy over here, which we can instantly say is just less than pi over 2, since we are subtracting an arctan of a strictly positive integer number. Fuck. So, and now what is this equal to? We do the exact same thing, and then we just end up, instead of going from 1 over a to infinity, we just have, well, yeah, we still have arctan u, but instead we get 0 to infinity, which is exactly equal to pi over 2. What have we shown here? We have shown that, and sorry, we shouldn't denote that this is less than pi half. We should denote that this is larger than something. What is this larger than? It is obviously larger than 0, since a is strictly positive. The biggest thing we can subtract here is just something approximating pi over 2. So therefore this is larger than 0. Okay, so for case a is larger than 0, we know that the sum is bounded between 0 and pi over 2. And that is great. And so yes, I will have to erase some things. Give me one. So now we're on to case number 3. That is when a is less than 0. And what happens then? Okay, so here we have an a squared, so that doesn't really change, but this one does. So here we could do a quick little variable substitution. So since a is less than 0, then we could regard this as u being equal to minus a, and then of course then the a from case 2. So therefore we would just get all the exact computation but just add a minus sign. So essentially what we would get is just that, like the sum would then be less than the integral from 1 to infinity. No, sorry. Yeah, it should be less. Yes, exactly. It should be less than minus the integral from 1 to infinity, and it should be larger than the negative integral from 0 to infinity. And we know that this thing here is just minus arctan of infinity, which is just minus pi over 2. And we know that this thing here was, is definitely less than 0 at least. So therefore it also holds for case 3. And obviously I have to write everything out more formally, but I think you get the point. Everything just flipped. So yes, that was everything for me. Hope you enjoyed the video. Have a good one. And now we're moving on to problem number 7.